Hello class, welcome to our lesson today. We're going to switch gears into chapter 6. This is what's known as the standard normal distribution. There is a PDF online or in your textbook. There should be a table that looks something like this. It says something about z-scores and negative z-scores, and then there's a second page that has positive z-scores. You're going to want to make sure to have that around basically for this whole chapter. We're going to be using that table exclusively in order to find some answers. If you use a different table and or different resources, you might get a slightly different answer, and that may cause some questions to be incorrect, depending on the situation. We will show some things eventually with some things with StatCrunch if the questions get a little bit more difficult, but for now, you're going to want to be comfortable being able to do these with the table that's on there. So you could use the one in your textbook or print one off. Either option would be fine to make sure that you're ready for these questions. So the main idea of what we're talking about is what's known as a density curve. Now this is actually a topic from calculus, so all these numbers are developed from some things from that from calculus ideas, which is find the area underneath the curve. So a density curve by definition always has an area underneath it that's 1, that's correlating to 100%. Every point on the curve has to be at least 0 because you can't have a negative probability. So same idea, you can't have negatives in the density curve. This first example is basically showing something that's what's known as a uniform distribution. We're not going to spend a lot of time with the uniform distribution. The idea is if you just make a rectangle out of this, it's from anywhere from 22 to 24 minutes is the length of the show. So you're saying, well, what's the probability it's more than 23.5 minutes? Well, you just find the difference in the distance from 23.5 to 24, which is 0.5. Then you divide by the total distance, which is 2, which is a fourth of that, which would be 25% or 0.25. I wouldn't focus on this idea as much as we keep moving forward here because this idea is not going to be used as often as what the next topics are. The important thing to look at is what's known as a standard normal distribution. So first off, normal distribution is a bell-shaped curve. So if you notice here, here's a bell-shaped curve. A standard normal is a distribution that has a mean of 0 and a standard deviation of 1. So you'll notice here that 0 is right in the middle, so right smack dab in the middle is 0, and then if you go to the right, it's positives, and if you go to the left, it's negatives. And it should be symmetric. This is a perfectly bell-shaped curve, and so positive 1 and negative 1, okay, those distances are the same, and the area underneath the curve in those areas are the same. What you'll notice here is we have something that's what's known as a z-score. So z-score is going to be our main focus, and that's what this table talks about, is negative z-scores and positive z-scores. Okay, that table is table 2A. You want to make sure that you have that. One side is the negative z-scores, which are the numbers that are less than 0 here, so like these smaller numbers that to the left. And then there's a side that's the positive, which are the pieces to the right. Every single value, and it'll make more sense once we see a picture, is wherever that value is on the chart, or on the table, excuse me, or the graph, it's finding the area underneath that curve to the left of it. Okay, so it's always area to the left. If you need area to the right, we're going to have to come up with some ideas about how to find that. But the table is the distance from that spot and then all of the area to the left of that. So here would be an example. So here is z equals negative 0.64. Now to read your chart, okay, so I'm going to try to read it along with you. What you'll notice is that the column on the far left is the tens place. And then at the top is the hundreds place. So you kind of have to match it up like a grid in order to find that. So I would encourage everyone to pause here and make sure that they can find these. These are the base cases. Okay, if I look for this this number in the table, negative 0.64, I'm going to go to negative 0.6 on the columns and 0.4 and match them up, and I should get to 0.2611. What that represents is if I draw a vertical line at the negative 0.64 and then fill in all the area to the left, the area underneath that curve is this, which is a 26.11% chance. If z equals 1.32, that's 1.32 standard deviations above normal, because remember, 0 is the base case, the mean, and that would be area to the left. Now, what you should notice here is this has got to be more than half, because this area is to the left of this, and it's at least half of this object. Okay, on the positive side, then you go to 1.32, so 1.3 on the column, 0.2 on the row, and match them up, and you should get 0.9066. Now, when I say all these things, the most common mistake is you just miss the spot. Okay, I may even do that when I'm plugging things in and I don't realize it sometimes when I'm making my table. But you want to match them up the best you can. If you notice that a number seems wrong, let me know. And it might be that I was off on mine too, because I like to use sometimes a ruler or another piece of paper to keep things organized. You may also find that circling numbers is helpful. You may have to print off a couple copies of that to make it worth your time, because once you start circling things, it's hard to kind of see other numbers. But again, this is area from that point to the left of that curve, underneath that curve, and that's what that would represent for those z-values or z-scores. The next one is 2.54, so go to 2.5 on the column, 0.4 on the row, match them up. It should be almost the entire table, or the entire area under the curve. Notice this is 0.9945. The area under the whole curve is 1, so almost everything is underneath the curve at that point. And if you think about it, that makes sense. That's 2.54 standard deviations above the mean, and that's what that's looking at. Negative 2.54 is just its kind of counterpart on the negative side. So if you go to the negative side of your table and go to negative 2.54, what you'll notice is this is 0.0055. Now here's what's cool about the z-score table. Since there's symmetry in the table, it's a perfect bell-shaped curve. If you needed the area to this, like on the right here, this 2.54, but you wanted the other area, you could do 1 minus this answer, okay, to find the area to the right, and that would be 0.0055. That also makes sense because the area to the right of 2.54 should be the same as the area of the left of negative 2.54. Because of the symmetry, it's like you're chopping off the same spot and then seeing what's left over. Okay, so some of the symmetry, you might come up with some shortcuts on your own. You can always do area to the left and subtract if needed, things like that as you're going through these situations. Okay, the next question is just the one base case scenario of dealing with an application that's centered around 0, and that's with dealing with freezing points of water in degrees Celsius, so it should be at 0 degrees Celsius. And some of the readings are going to be above or below, and it's normally distributed. So this says find the probability that the freezing point of water on the reading, okay, the reading of the thermometer, is less than 1.15. Now, first off, we should probably assume that it's probably below 1.15. Because if it reads 0, it's supposed to be at 0 anyway. So what I'm looking for is a less than. So less than 1.15, this would be the picture. And I would encourage you to draw some of these pictures out. I know it's tedious and sometimes annoying, but I think it'll really help when it comes to finding these areas. I'm looking for z less than 1.15. So I go to 1.15 in my table. Okay, that would be on the positive side, the second side. I go to 1.1 and then 0.5, and that'll be 0.8749. And that's what I want. I want the probability it's less than. So that less than would be area to the left, because all those z-score values are less than 1.15. And I add them all up and I get 87.49%. The next one says I want the reading to be above negative 1.34. I can draw that out. Here's negative 1.34. It's less than 0. I draw that, but I want numbers above. So I want the area actually to the right, not the area to the left. So what I've done is gone to negative 1.34 on my table. And once I find that, I match those up, negative 1.3 and 0.4, and that's 0.0901. Make sure you're able to find that on your table. That's area to the left, so that would be this part here that I don't want. So the idea is this is like the at least, or like the opposite of whatever I want. So if I do 1 minus that, I'm going to get the area to the right. And that's the idea that you're going to want to use a lot when we get to these questions with the z-score table. You're going to want to practice this. You're going to want to make sure you're able to find things fairly quickly, okay, to be able to find that. If you want area to the left, less than scenarios, it's just the number in the table. If you want the area to the right, you're going to have to do 1 minus the number in the table in order to find that answer. There are some symmetry pieces if you want to learn that idea as well. Maybe you could talk to me about that more. That might help you deal with the subtraction a little bit easier. It kind of depends on the scenario. I figure just focusing on one thing at a time right now, since the table's new, might be the best option for you as you're looking at those scenarios. Okay, so just make sure you have one of the tables, either print it off or find one online that on the PDF, or use the one from the textbook. Some tables are a little bit different, so you want to use the one that's from our textbook as we're going through these situations. Then we should all have the exact same answers as we're going through them. Remember, the columns is the tens place, the rows the hundreds place, and you match them up to figure out where the 4-digit number, the 4 places after the decimal point, and that's how much of the curve is to the left of that number on the z-score chart. We're going to continue this idea in our next lesson. Okay. In the meantime, make sure you practice some of those ideas with finding the numbers and finding the z-score values and the probabilities that correlate with it, and then we'll apply that to some other applications in our next lesson. Have a good day, everyone.